All right, today we're going to start chapter 3, which is going to be talking about parallel lines and different angle pairs formed when we cut those parallel lines with a transversal. So today we're going to talk a little bit about some vocabulary and kind of start getting into what are the different types of angle pairs, what is a transversal, and how do we kind of work with these lines as they intersect. So the first thing, we talk about parallel lines, which you probably discussed in previous math classes. I know in algebra you would have had graphing where you were graphing parallel lines and things like that. So with parallel, in geometry, what we're talking about are two or more lines that are in the same plane. So they have to be in the same exact plane that never intersect. So these are going to be two lines that never touch. So for the most part, when we talk about this in the same plane, we want to talk about going in the same direction. So that's another way of thinking about this. We need two lines that are going the same direction that never intersect. So down below here, we have line L and line M here. Now if we look at those lines, they're both going exactly the same direction, and those two lines are never going to actually meet up and cross, whereas like a line like this and a line like this, in my picture, those two lines don't come together, but eventually, if I were to continue them on, they would end up intersecting at some point. So these parallel lines have to go exactly the same direction the entire time. So they can never cross over or never get close to crossing over. In real world, so off to the side that you got a picture in the real world, you can see parallel lines everywhere, like shelves in this case, or bars, the tops of the plaques versus the bottom of the plaques, the top of a whiteboard versus the bottom of a whiteboard. So anything that's going the same exact direction and never coming together and meeting is going to be considered parallel. Now, similar to that, but a little bit different here, is going to be what we call skew lines. So with skew lines, we have two or more lines that are not in the same plane, and they never intersect. So they're just like parallel lines in that they're never going to touch each other, but now we have not in the same plane, meaning not the same direction. So we're thinking they're not going the same direction, so they're not going to intersect. So if we look at the picture down below, now this plane, and so sometimes these three-dimensional figures are sometimes hard to visualize. You have to envision this plane that I just highlighted as just lying flat. So imagine it's like a piece of paper sitting on your desk. Now line K, so this line right here, is coming down. So if you're thinking about this piece of paper on your desk, line K would be like something coming straight down and going through the middle of your desk. So this line K is going down, hitting your desk right here, and then it's going below your desk. So it's actually piercing right through the middle of your desk. On the other side of that, we have line K, or J. Line J here would be lying on that paper on your desk. So on that paper, you've got line J lying right on the paper there, and then you got line K, which is going through the middle of your desk, just straight down. Now, if we look, what we notice is because they're going two completely separate directions, and we notice that because one's lying on the desk, the other one's passing through it, these two lines never actually intersect one another. So when I look at line J here, and I look at line K, they're not actually going to intersect, even though it somewhat looks like it right here. That's not actually a cross because the two lines aren't touching each other. The one's flat on your desk, the other one's passing straight through your desk. Another way of looking at this would be off to the right here. We see like this bar here going in this direction, and then the second bar over here going this direction. If we were to extend those lines, those two lines in red are never going to touch each other. One's going straight up and down over by the wall, the other one's going kind of a diagonal over along the floor there. So skew lines go two completely different directions, never touch. Perpendicular lines we've talked about before. And so with perpendicular lines, these are lines that come together and form right angles. So they're going to make a 90 degree or a right angle. The symbol we use for perpendicular is going to be like this upside down capital T. So when I want to say two lines are perpendicular to each other, you're going to see that symbol there like down here. They're saying line A is perpendicular to line B. Typically, perpendicular lines will be denoted with that little box in the corner. Anytime we're going to have right angles, they're going to have that little box there to show you that that is in fact a 90 degree or a right angle. So any lines that are perpendicular are going to be right angles. So if we talk about these different types then, so how can we identify these within a more complicated picture? So the first one or question here says name a pair of parallel lines. So I need lines that are going to be going exactly the same direction and never going to end up crossing. So I've got like this box off to the right. So think about that as like a box sitting on your desk. So I need lines that are going to go the same direction, never going to cross. So for instance, I could choose line AB here, and I need another line that goes exactly that same direction. So I was going straight left to right. So I might pick line CD up front here. So line AB is parallel to line CD. This is something we might have glossed over on the previous slides. This symbol here, where you have the two lines next to each other, that stands for parallel. So when you want to make a statement, one line's parallel to the other, you can just use that symbol. So line AB is parallel to line CD. Those aren't the only sets of parallel lines though, like maybe I had chosen line CE instead first. Well, if I want line CE to be parallel to something, I need something else that's going straight up and down. So maybe I come across here to line DF. So that's another pair that we could have used. Line CE is parallel to line DF. And so on and so forth throughout the entire picture. There's lots of parallel lines hidden kind of throughout the picture there. So we got those options. If we look at the next question, it says which segments are parallel to line CD? So in this case, the first thing we'd want to do is kind of highlight. Line CD is this line right here. We want any lines that are parallel to it, so any lines going the exact same direction. So if we look at the picture, all lines going straight left to right are going to be what we want. So we've got line AB off to the side here. And then we have line EF down at the bottom here. And then one that's a little bit trickier, but it's still going in the same exact direction as CD. So anything going left to right is this one way back in the bottom corner here, HG. So even though HG is not directly connected to CD, it's going the exact same direction from left to right. So it is also parallel to line CD. So HG would be a third line parallel to CD. Okay, so be aware of that even if they're not directly connected, they're still going to be parallel if they're going exactly the same direction. Now as far as skew lines, so if we're looking for skew lines here, again, those are ones that go different directions and do not touch. So I just pick a line to start with. Maybe I pick line CA here. So just give us a different direction. So line CA is skew. There's no symbol for skew, so you just have to kind of write it out. So line CA is symbol or skew 2, and we pick another line that goes a completely different direction. So this one's going front to back, so I need something going either left to right or something going up and down. The thing is, I can't pick a line that's going to touch line CA, so I can't pick line AB, for instance. In this situation, they are going two different directions. One's front to back, one's left to right, but I notice that they come together and meet right here. So I can't use that. So instead, I got to figure out a different line going a different direction that's not going to touch. So maybe I come down here to HG. So line CA would be skewed to line HG. They're going two different directions, front to back and left to right, and they're not going to touch. So purple and green are never going to touch each other. For some other quick examples, we could use, for instance, line CD, so something going left to right, with line BG going straight up and down back here. The blue lines are never going to touch because CD's out in front, BG's way in back, and they're going two completely different directions, side to side and up and down. So with skew lines, you're just looking for two lines going two different directions. Do not let them touch. So I cannot ever let the lines that I choose touch for parallel or skew. Okay, the next question says name a pair of parallel planes. So if we're talking about the idea of parallel, that's two planes going exactly the same direction. So the first thing I would have to do is just pick a plane. So I might pick this top piece of the box. So the top piece of my box there, if I want to name it, I use the word plane, and then I can use 3 points on the plane, or I can use all 4. But if I'm naming 3 points, I'd maybe call it ABD. So plane ABD, that's the top piece highlighted in pink, is going to be parallel to plane, and then here's where we got to kind of think about what's going on. Parallel means going exact same direction. So my plane on top is going left to right and front to back, so it's laying flat on top. So I need a plane that's going to be just like that, but in a different location. So here we have the bottom of the box. The top of the box and bottom of the box should be parallel to each other. So plane ABD could be parallel to plane HGF. Top parallel to bottom. Or we very easily could have gone left parallel to right or front parallel to back. So it's just a matter of picking the plane, labeling it with the points, and then just putting the two pieces together. As far as perpendicular lines, so since this is a box, that tells us that all these lines that meet are going to be at right angles. So anywhere we look, we're going to have right angles where we have our lines meeting together. So all I need to do is pick two lines that seem to meet up together. So for instance, I could choose line AB, and then I want any line touching line AB. So any line that's going to come together and hit AB. So for instance, BG. So with these perpendicular lines, if we're looking at this box, we're just looking for any lines that intersect. AB and BG would be perpendicular, and then don't forget the symbol for perpendicular if you want to use that. Okay. Next big thing, vocabulary term again, transversal. So a transversal is any line that intersects two or more lines. So it's one line cutting through a bunch of others. So it's going to cut through them at different points. The lines may or may not be parallel. So in this first example, line L is parallel to line M, but in the second example, they're not parallel. It doesn't matter whether lines are parallel or not. Transversals are any line. So like line T here cuts through L here and cuts through M here. That's a transversal. Line T over here cuts through L here and M here. That's a transversal. So T is the transversal of lines L and M in both situations. So when we're looking at those transversals, it's one line cutting through other lines. Okay. Now when we have those transversals, there are 8 different angle pairs that are formed by those transversals. So I have these two lines here on top and bottom, and they're being cut by a transversal. Whoops. They're being cut by a transversal here. Okay. So the different types of angles that we can encounter with this situation. The first is called alternate exterior. Alternate, you want to think of like opposite sides. And exterior obviously means outside. So what we're talking about here are outside angles. So outside, this is the exterior of my figure. This is the exterior of my figure. And then on the inside of my figure would be the interior. We're talking about between the lines. So I'm between the two green lines is my interior, outside the green lines is my exterior. So if we go to our exterior angles, we want angles that are on the opposite side of orange. So here I've got angle 1 on the outside. I need to go across to my second group. So if I look at, when I'm looking at this transversal, I'm jumping from one group of angles to the other. So I want to jump from 1, 2, 3, 4 down to 5, 6, 7, 8. So I need another angle on the outside, but that's on the opposite side of orange. So the only angle that works for that would be angle 8 here. So for alternate exterior, angle 1 and angle 8 would be exterior or alternate exterior angles. Or we could use the other pair of angles that we see there. Angle 2 is on the outside. So if I jump down to my other group of angles, I want another outside angle, but I got to be opposite of orange, so 2 and 7. So angle 1 and angle 8 would be alternate exterior. Angle 2 and angle 7 would be alternate exterior. When I look at my next pair is what we call alternate interior. So alternate meaning opposite, interior meaning inside. So I pick an inside angle, like angle 3 here. And if I want to pair it with an alternate interior, I need to be inside my two green lines still, so either 5 or 6 down here, but I need to be opposite of orange. So So I need to be on the opposite side of orange, which would take me to angle 6. So angle 3 and angle 6 would be my alternate interiors. Or I could use the other pair that we see there. Angle 4 is also on the interior, so I could pair it up with its alternate interior 5 to get another angle pair. So angle 3 and 6 are alternate interior, angle 4 and 5 would be alternate interior. If we continue that then, the next type of angle is called corresponding. Now corresponding is kind of like saying same position. So these are going to be in the same exact position, meaning when I pick one angle, I need the other angle that's in the exact same position. So angle 1 here is in the top left. I need the angle down below that's in the top left as well, which would be angle 5. So angle 1 and angle 5 would be corresponding. Or any angle pair that's in the same location. So I could also have angle 2, which is the top right, with angle 6, which is also the top right. So angle 2 and angle 6. Or if I'm following that same pattern, I could have angle 3 and angle 7. Or I could even have angle 4 and angle 8. So any angles that are in exactly the same location, so top left with top left, top right with top right, and so on, those are corresponding angles, same exact location. Same side interior angles. So for same side interior angles, now we're looking at the interior again, but now we're saying same side. So we want to be on the same side of the orange. So for instance, angle 3 here is on the inside. The other angle that's on the inside and on the same side of orange is angle 5. So angle 3 and angle 5 would be an angle pair. Or we could use angle 4 here and pair it up with angle 6. They're both inside and both on the same side of the orange line. Now one thing to note here, same side interior angles will sometimes be called consecutive interior. So just be aware that there's the term consecutive that you might see. It means the same thing. So it's both inside, both on the same side of the transversal. So if we're looking at a situation like this, so it says name the transversal and then name the angle pair for each of the different angles. So they're giving us an angle pair. What's the transversal and what is the angle pair? So when you think about transversal, you're looking for the line that touches both angles. So the transversal is going to touch both angles. So if I'm looking at angle 2 and angle 7, if I mark those angles in my picture here, so angle 2 and angle 7, I'm looking for the line that hits both of those angles. So if I look at P comes down here, it touches angle 2 but doesn't come close to angle 7. Or I might look at line Q, it touches line 7 or angle 7 but it doesn't even come close to angle 2. So I needed the line that hits both. And so in this case, the only one that does that is line R. So line R is my transversal. And then it says, what's the angle pair? Well, if I look at my angle pair, notice angle 2 and angle 7 are inside P and Q. So they're inside P and Q, that makes them interior. And then since they're on opposite sides of R, that means they are alternate. So alternate interior angles. And this is the abbreviation you can use for alternate interior. And so if I use that same process here for the rest of these, we just kind of highlight the angles that we're identifying. So angle 7 and angle 15, I got 7 here and 15 here. The line that touches both angles. So the only line that goes through both would be line Q. So there's my transversal. And then if I'm looking at what type of angle pair they are, if I look at 7 and 15, 7 is my bottom left angle, angle 15 is my bottom left angle. They're in the exact same position, which means I have corresponding angles. And again, this is the abbreviation you can use for corresponding, but they're in the exact same position to each other. Okay, if we look at the next example, angle 12 and angle 13. So if we highlight 12 and 13 here, I'm looking for the line that cuts through both. So the only line that touches both angles would be line S. So there's my transversal. And then if I'm looking there, that means I'm looking at these two lines being cut. The 12 and the 13 are on the outside. So 12 and 13 are on the outside, which means they're exterior, and then they're on opposite sides of S. So that would be your alternate exterior angles. And again, there's an abbreviation you can use for alternate exterior. Okay. The last one's 11 and 10. So if I'm looking at angle 11 and 10, here's 11 and 10. The only line that passes through both would be line S. So there's my transversal. And then if I'm looking there, they're both inside the two lines being cut. And so they're interior angles. And since they're on the same side of S, we just write same side interior angles. Or you might say consecutive interior angles. Okay, so either phrase would work, same side interior or consecutive interior. Okay, so being able to name what transversal it is, so what's the one line cutting through both angles, and then what's the angle pair. So you have to be able to identify those different angle pairs. We're going to do more with these angle pairs tomorrow and the next day, talk about different special properties and things like that. But for now, all we're asking you to do is be able to identify them. So with this, you should be able to complete the worksheet for today. If you have questions on any of it, make sure you ask in class, make sure you email, come in before school, whatever you need to do to get some help. But everything should be good to go. Using these notes, you should be able to complete your worksheet from there. So let us know if you have any questions.